Hello, and welcome to another lesson with Professor Checo, Pre-Calculus for Business. And today's lesson is 7.2 sets. All right, let's go to the textbook, 29 questions, and textbook. So I'm assuming these are going to be sets like Venn diagrams. All right, set properties and set notation. We think of a set as a collection of any object specified in a way such that we can tell whether any object is or not in the collection. Capital letters, ABC, help distinguish, designate particular sets. Each object in a set called a member or an element. So if A is an element of A, that means that A is an element of A. And here A is not an element of A. A set without any elements is called the empty set or the null set, and so forth. And we typically use like the circle with like the line through it to denote the empty set. All right, so basically just going through it and identifying a bunch of that, moving on. So here, A is a subset of B, A is equal to B, A is not a subset of B, and A is not equal to B. So just kind of going through those definitions and so forth. Venn diagrams and set operations. So here's a Venn diagram. The Venn diagram in figure 1 can be used to picture any set A and universal set U, the universal set. All right, so here you go. So it's just that they got some examples like capital, lower, whatever. Here, this is what they have in common. A and B, the non, and you guys should know how to read that. So here, this is A union B and A intersection B. So I kind of think of U, the union, U, intersection, second letter is an N, N. So A union B basically means A or B, and A intersection B is A and B. Okay, complement. So here, if you look at this example, so the complement of A would be everything that's not an A. So it's everything that's in the universal and everything that's in B. So there you go, that would be that region. There you go, that's a complement. All right, so going through the set notations, truth tables, a little bit, numbers, moving on, just some examples, insurance. Okay, I think that's going to be it. So it should be pretty straightforward, actually. All right, is the set of positive rational numbers a subset of the set of integers? So if you kind of think of how your numbers are, integers are positive and negative numbers, where that is going to be blah, blah, blah. Is the set of positive rational numbers? No, because a subset of the set of integers? Yes, because integers includes positive and negative. I think it's actually the other way around, because integers are not contained in a set of positive. No, it's no, because the set of positive is not contained in a set of integers. That's what it is. There you go. So positive rational numbers is a subset. Other way around. Okay. Is if the universal set is the set of real numbers, if the universal set is the set of real numbers, is the set of negative real numbers the complement of the set of positive real numbers? So if we talk about all real numbers, you have positive and negative. The only thing that I'm contemplating is 0. So I'm going to say I want to say it's 0. I'm going to say A, but I'm going to say it's going to be 0. Yep, because it doesn't contain 0. There you go. I said that in the beginning. All right, indicate if the following is true or false. 1 and 8 is a subset, is an element of 1, 3, 4, 8. So 1 is, 8 is not, so this is going to be false. Indicate whether the statement is true or false. C, G, J, I, C, G, J, K. Yeah, this is true. These is equal. Determine whether the following statement is 5 is an element of 5, comma 5. This is true. That's just 2 ways to write it. 13 is in that statement. False. 0 and 6 intersection 1, 6, and 9. The N stands for intersection, would only be equal to 6. Write the resulting set using the listing method. 3, 6, 7, 3, 7, 9. So that'd be 3 and 7. So that'd be 3, comma 7. Oh, union. I'm sorry. It's not the intersection. This is union. So it's all of them. So 3, 6, 7, and 9. So 3, 6, comma, 7, comma, 9. There we go. Let's see. 1, 4, 7 intersection 2, 6 is the empty set. Nothing in common. X, write the resulting set using the listing method. X such that x squared is equal to 81. So I'm going to go with negative 9 and 9. Not 0.9, comma 9. Oh my goodness. Delete comma. Cool. X is an even number between 4 and 12 inclusive. So what would my set be? 4, 5, 6, 7, 8, 9, 10, 11, 12. 4, 5, 6, 7, 8, 9, 10, 11, and 12. And listing notation. Oh, even numbers. My 4, 6, 8, 11. Let U and A find the complement of A. So find the universal is that, A is that. So everything that's not in, basically what's in A. So we're going to go with 2, 3, 4, 2, 3, 4 commas. Oh, missed it. There. Enter. Got it. All right, for the Venn diagram to the right to find the, all right, so what is n of b? So what are the numbers that are possible for b? So if you look here, everything in b should be 36 and 28. So 36 and 28. No. Type a whole number like, can I do it? No, this and this. No, this. Or an A would not B. B but not A. You think it's just 28? 64. Oh, I have to add them? Oh, I didn't know how to add them. Okay. I did not know how to add them. All right, that's 68. Got it. A and B. So it's 21. It's all these three. 2, 4, 5, 58. Let's see. The complement of A would be 30 and 40, which is 70. Everything not an A. All right, here, what is B and B complement? So if you think about this, it's what is the set plus everything outside of the set. So it's going to be everything added up together. So let's do, this is 60, 77, 77, 7, 8, 90, 98. I think it's 98. Add them all up. Select the correct choice below and fill in the correct answers. So x is an element of R or x is an element of T. RT, so we're going to write all of them out. I think you guys kind of get this, right? It's trying to get the hang of it. All you do is find the intersection. Determine whether the given set is finite or infinite. So here, because where n is greater than 170, it's infinite because the positive integers starting at 1, so it can continue until they reach without an n. Any number greater than 175 goes all the way up to infinity. This is finite. What does this show? Draw a Venn diagram for sets A, B, C, and shade the region, the complement of A with B and the complement of C. So intersection. So it's the intersection. It's B. Where does, I want to say, I think it's just this region right here, because anything outside of B, anything outside of, I'm sorry, anything outside of A, anything outside of C, I think it's just this region. which would be A. Pretty confident. All right, pretty same thing. Consider the positive values sets are defined to the right, determine whether the sets are disjoint. All right, so let's see, H and H prime. So H and the complement are going to be, I think it's, are they disjoint? So if it's n is greater than 100, then this one should be less than or equal to, but they don't, I'm going to say yes, they're disjoint. They don't share. They don't share anything in common. Consider that determine whether the set have H complement of E and the complement of H. So here the complement of would be everything less than 100. So we're going to have numbers that they're going to be joined. All right, cool. If A is an element of B, then A intersection B is equal to A. True. If A and B is equal to A, then if A union B is equal to A, then A is an element of B. That means that B is within A. A is a subset? No, B is a subset of A. How many sets does each of the following contain? How many subsets? One question mark? The set A has how many subsets? 0? I have absolutely no idea. What would the answer be? A. The set has how many subsets? Infinite? Can I go infinite? 2. Why is it? Oh, because it's A, so then this one would be 3. No, this was 4. Let me try 2 again. I think it's maybe 4 or 5. 4. And this one, 1, 2, 9, 6. 7, 8. Oh my goodness. I'm sure there's a reason why. Is it just times 2 times 2 times 2? No, because that's 3. How do you get 8? I know what they're talking about. So it's like A and the empty set. Here it's A, B, and the empty set. Here it's A, B, C, A, B, C, A, B, B, C, A, C, and the empty set, right? So this one would have 15, 14, or 2, 4, 8. Did I try 16? I tried 16, right? 16. I don't know the formula. There's definitely something there. Let me see the textbook. What does it take me to? No, there would have to be a formula, right? There's complement, the universal set. No. No, they didn't tell us. Alright, whatever. Interesting. It's the same answers. What was this one? This one was 2. The next one was 4. 4. And then it was 8. And then it was 16. I'm basically just doubling it. 2, 4, 8, 16. I bet the next one would have been 32. Okay, so what's the probability of B intersection S? B 26. How many ways can a 4-person committee be formed using the president and 4 vice presidents? Management of company president and 4 vice presidents denoted the set boom wish to be selected in a committee of 4 people from among themselves. 1, 2, 3, 4. I think it's 5 choose 4. Am I going to do this? Combination calculator. And I need objects. It's 5 people and my sample is 4. Calculate 5. There are 5 ways I could do it. Okay. When receiving a blood transfusion, blah, 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 a person, what blood types are included in B union RH? B union RH. So everything here and everything here. So we got the big one. Holy smokes. The only one I don't have is A negative, which is this guy right here. A negative, and it's obviously a lot more than that. And that was it. Awesome. So I can definitely say that Chapter 7 has been a lot easier than Chapter 6. So I have lessons 3, 7.3, 7.4. That would be next week. So 8.1, 8.2, 8.3, 8.4, 8.5, and then we're going to have quiz 4, and that will lead us to our final. Awesome. Best of luck.